G'day Bifrosters, welcome to the Worley Fix. I'm sorry, I noticed that while I was making a video for the next phase of the noise, which I'm still going to release pretty much just with notes all over it, I noticed that I screwed up the distance metric. So what I was doing in my old Worley, which we can access here, Worley VIII, which is pretty much the same one I put together for you guys, is that. So what I was doing was evaluating the curve after the metric, and that was completely screwing up the distance metric, as it's probably obvious. So here's the fix. So not only is this a better place for the metric, looking at just the single Worley right now, nice bit of sexy lighting, all of that kind of thing. So not only is it better for the metric, and you can see that this is the difference. So I'm doing adjustments to only the Euclidean distance metric. The Manhattan and the Chebyshev are going out straight. There's no differences there. But not only have I fixed that, I have managed to make the Worley a little bit, I know we're diving in through like 3 or 4 layers of stuff at the moment, but I've managed to make the Worley just a little bit more efficient, as it were. So we've got a couple of things here. Let's take you through it real quick, and then we'll go on with the noise video, and I'll just show you a couple of things. Worleys need seed points. They need the way they work is that you scatter a bunch of points across your object, and the noise value is the distance between your point and the closest seed point. We know this. We've done Worley before. We've talked about Worley. So what I've done now is I actually have a seed generator here, which allows me to choose how I'm going to scatter things. Ignore that because that isn't really there. That was slowing things down really, really heavily. So a lot of what's going on in this Worley straight away, the Worley 2, is you've got geometry coming in, you've got your Worley frequency, you now have got 3 scatter types. The volume isn't really there. It was there, but it's not there now. You've got scatter by bounds cube, so that's the bounding box, scatter by bounds sphere, which is like the bounding box, but a sphere, and that's what this one is using, and scatter on object. And the way those are doing that, I don't know why it does this. If we jump in here, so this is how it does the cube. It scatters random points in a cube, and you can actually set up your, this is another compound I'll be releasing, but you can set up your width, height, depth, and center, or you can just plug a cube into it, and it'll scatter points into that cube. Then you've got sphere, which again, you bring your object in. This is the bounds node with some edits. So you can see it's still got the min-max bounds, out bounds coming in, but I've now also put out the radius and the center, which I'm plugging into a points in the sphere. So that's how that one's working. But what it brings is the padding with it, which is nice. And then you can scatter on the object, which is using Bifrost scatter, which means you can change the density weights from random to distance based. You can change the amount mode from number and density. You can also change the scatter mode, which is not done here, obviously. It's done back out in the menu. So you can take advantage of things like the blue noise and stuff like that. So that's how the scattering of the points are done now. And we can turn those on here so we can have a look at them. Although they're not going to be terribly visible inside of that. There they are though. So that's the first big change in the Worley noise. Let's go back to using all the lights, shall we? Because it's quite pretty. So there's now a scattering feature in the Worley noise. I'm going to release the Worley noise nodes as per, and I'm also going to release this by itself. So as a sort of a feature point scatterer. The other difference in the new Worley noise is that instead of going through 2 loops, I've now done it implicitly and just gone through 1. So we're inside the loop at the moment. This is the loop. For each in mesh points, it's actually a for each loop. You can tell because there's a current index on it. So it brings in all of the mesh points and all of the feature points. It loops through every single mesh point like this, subtracts the feature points. Everything from here is distance calculations. So up here you have your Euclidean distance. So you've got your distance, which is just a length node, and it sorts the array, and then it gets from array, and this is our friend n. So this is the index we're getting from the array. Usually 0 if you want a nice curvy Worley, but sometimes 1, sometimes 2. We went through this in the Worley episode. Then down here we've got an absolute value, converting the vectors to floats. And then this is the Manhattan, where we're adding them up, sorting the array and taking the nth value. And this is the Chebyshev, where we get the longest one, sorting the array, getting the nth value, and then output. And this is just the choice. So you're outputting Euclidean, you're outputting Manhattan, you're outputting Chebyshev. We're doing an adjustment on the Euclidean that we're also porting back out to the user, which is the adjust shape here. And then this is just all of the if statements and cool stuff like that for our cases. So that's just a switch that says, you know, if this is set to Euclidean, then go out here. If it's set to Manhattan, go out here. If it's set to Chebyshev, go out here. So it's a much more compact and easier to use Worley Noise, and it also has the ability of having a lot more options. And then, just like we did in the other episode, the Worley F2 is pretty much exactly the same setup, except we've doubled these up. And we've doubled these up, and we've doubled these up. And then again, we've got F1 and a math function and F2. And the math function sits here, so 3 plus 2, or 3 minus 2. And this will change probably. Yep, maybe, just a little. Ah, no, it won't, because we haven't got that switched on, so I'll switch that on and we'll have a look. It's not tremendously fast, and I'm still working at fixing it up. Getting a little faster, but go back to the plus. There you go. We've got padding now. So on all three, remember that volume isn't really there. All three scatter types we've got padding, so I can pad that out by 5, and this will change in a minute. There we go. So we've got a different padding. And that's the same as if I go for a cube. But this is expanding the bounding box, the bounds cube out, and this will do the same for the sphere. So we'll go to sphere, give it a second to sort itself out. I'll change the bounds back to 0, and you can watch stuff change. There we go. Doesn't really show us much, but this is getting us our really nice patterning now that we weren't getting before, because I was essentially doing the distance checks and then quite happily undoing them with an F-curve. There we go. That is the new Worley. I'm going to still release the other videos. Worley 1 and Worley 2 will stay as they are. The next noise update I've done is we're adding detail to the noise and tidying a bunch of stuff up. I'm going to leave that as it is too, but I will put notes in here, and I'm going to upload this first. So this is the Worley Fix video, the Worley addendum. And you can see over here I've already added it to the noise. If we come into the NoiseWorks, it's now Worley 2 in there rather than Worley. I need to rename that one so it doesn't confuse myself and everybody else in the world. Well, all 251 of them. So this is what the new noise node looks like. You don't know about this because I haven't uploaded the video, but give it a sec. I'm still working on optimizations, and of course when I've worked out the optimizations I will let you know as well. Just having a big old think about this. I also think perhaps I'm taxing my machine a bit, but there we go. That's got us back to our nice Euclidean Worley. Can turn off those points and turn on those points, and they'll come in as a different color, and you can see the relationship there. And as you can see, if I go back out to the NoiseWorks node, the NoiseWorks now has a lot more settings, especially in the Worley, and we've got the on object bounds, volume, etc, that we had before. Volume of course isn't going to be there in the final. We've got random blue noise and blue noise maximal. We've got Euclidean, Manhattan and Chebyshev. So yeah, I have now adapted the NoiseWorks, which I will upload for everybody, to take the new Worleys, and the new Worleys are a lot simpler to use. Alright, so again, my apologies, I screwed up. That's the really nice thing about Bifrost though, is I was able to go and fix it, copy what I'd done to fix it and paste it back into here, and didn't hurt anyone. if you want to fix it yourself, you can grab the compounds I'm going to upload, or you can basically go through the Worley that I've done and find that last evaluate F curve and move it so that it only applies to the Euclidean, and you should get the same result. Okay, thank you very much, and I'll see you next time.